Hi, and today I'd like to talk about telerehabilitation based on XR. Here shows the outline of my presentation. And the first one is about examples and use cases of XR product, service, prototype, or research project for rehabilitation. I aggregated about a dozen of examples with my colleague, like this table. And then each column indicates name, features, users, target body part or target symptom, and which XR is used, how to use XR, and people involved in the XR environment, organization, country, node, and URL. And from now on, I will show you each example one by one. The first one is XR Health.
It's a fact that your health dictates your life. So it's time to put your recovery in better hands. Welcome to XR Health, a virtual reality telehealth clinic. You can now get professional medical treatments right at home. Meet with your XR Health clinician online, discuss your symptoms, and begin your path to a better, more enjoyable recovery. Your recovery will use a state-of-the-art virtual reality system, which will be sent right to your door. Welcome to the future of healthcare. Thanks to VR, 97% of our patients enjoy their recovery with XR Health. But more importantly, report a faster recovery than traditional treatments. We use virtual reality to guide your recovery in a simple and practical way, keeping your treatment fun while at the same time sending valuable data to your clinician. You can even track your progress on our dashboard, watching your recovery in real time. XR Health.
And
Experience,
the
analyze,
coverage
get
of
better.
this service is very broad, from physical symptoms to neurological or behavioral symptoms. And also this system and the service has FDA-registered medical VR applications. This CIVO VR is designed to engage the client involving daily functional activities through a virtual ADL rehabilitation system to help the brain reprogram itself and form new neural connections. And in the system, virtual assistant appears on the screen to educate and facilitate performance by providing real-time feedback. And this system also FDA-cleared system. The target users are patients with cognitive or upper limb impairments. Then in this system, the HMD is not used. Instead, the ordinary monitor is used. And then a variety of ADL-focused virtual worlds are provided. Then the Microsoft Kinect is used to measure the basically the upper body movement. And then this one is about Mind Motion Go. This is gamified neuro rehabilitation therapy platform for medium and light severity impairments able to be deployed in the patient's home. And that includes rehabilitation exercises for the upper limbs, trunk, and lower limbs with audio-visual feedback and graphic movement representation for patients. And this also FDA clear system. The target user is a stroke survivor at home, and then target body part is broad. And then in addition to Microsoft Kinect, lip motion is used to measure the detailed finger motions. This one is professional version of Mind Motion for hospital use. It is designed for acute neural rehabilitation and ideally suited for delivering tabletop therapy to patients recovering from upper limb hemiplegia. The gamification again is used in this platform, and then this is also FDA cleared system. And then the user is acute stroke patient at hospital. And then the system project computer graphic depiction of non-functional one hand, which is controlled by patient movement of working another hand, which is a kind of mirror therapy. This is MediVR Kagura. Kagura is Japanese traditional dance performance. This is also a gamification platform that provide seated reaching motion that is supposed to improve postural balance and dual task cognitive processing function. And then there are 5 different kinds of games. And then the target users are stroke patients. This rehabilitation system gives the feeling of walking in a grassland or a place with beautiful scenery to increase motivation by make the user use foot pedal exerciser like this. And then the target users are elderly people who wish to improve their motor skills, and the target body part is lower limbs. And then the provider gives us lots of kind of 360 virtual tour contents like this. This is the KIMBIS system. KIMBIS stands for kinesthetic illusion induced by visual stimulation, which is described as a feeling of one's body movement during sensory input, even though the body is actually in a resting state. Then the system provides cognitive stimulation to the embodied brain system for body ownership, a sense of agency, and the kinesthetic perception. The target users are patients with chronic stroke, and the target part is upper limbs. And this is also kind of a mirror therapy, but the difference is to use pre-recorded hand movement. And the system also sometimes applies the electrical stimulation while watching the movie during the finger extension phase. This is about phantom motor execution facilitated by machine learning and augmented reality. This is a novel plasticity-based non-invasive treatment for phantom limb pain, in which phantom motor execution is decoded via machine learning, while visualization of the phantom is accomplished via augmented and virtual reality. And this system, through the AR or VR representation, the system presents the virtual arm in the automatically correct placement. Next one is about Walk Again project. First feature is that the brain-machine interface with VR makes the patient's brain reacquire the notion of walking. And the second one is that by walking in a custom-designed exoskeleton with BMI, patients are eventually able to rekindle their remaining nerves to send signals back to brain and reactivate some voluntary movement and sensitivity. The target users are paraplegics, and then the VR system presents visually the virtual lower limbs through the HMD and the sense of touching the ground through haptic display attached on forearms. The next one is about an immersive simulation system for overcoming fear of heights. Through this system, people with acrophobia stand on top of a virtual skyscraper to alleviate fear. The next one is a Recover project done by the University of Queensland. The prototype system provides varied context for people to practice their communication skills, build confidence, interacting with others, and generalize their communication skills to various environments. The target users are people with communication disorders, and then the system simulates social communication situations that are difficult to create within the clinic in realistic, personally relevant, and safe environments, such as cooking. And also, in this system, the user can talk to others through virtual avatars. And then, yeah, that's all. The last one is Brave Mind, that supports exposure therapy, in which a patient with PTS, guided by a trained therapist, confronts their trauma memories through a retelling of the experience. The target users are veterans with urgently needed options for PTS treatment. Our next topic is very short introduction of market report and review. This is a market report titled Global Virtual Rehabilitation and Telerehabilitation System Market Growth, status and outlook from 2021 to 2026. Now I'm thinking about buying this, and so that's all for today about this. And this is a review paper titled Clinical Application of Virtual Reality for Upper Limb Motor Rehabilitation in Stroke, Review of Technologies and Clinical Evidence. And I just found this during preparation of today's presentation. And 3 examples I introduced today are also included in this review paper. So I will merge my presentation with this review paper for future use case reporting. The last topic is about the introduction of our new NEDO project. NEDO is a Japanese governmental organization. The title of this project is Multimodal XR-AI Platform Development for Telerehab and Reciprocal Care, coupling with health guidance. Well, we focus on rehabilitation and specific health guidance out of many kinds of healthcare services. And basically, economic, spatial-temporal, and cognitive constraints have caused a lot of issues and problems like this. So the purpose of this project is to solve and mitigate those issues. And basically, the issues caused by spatial-temporal and economic constraints can be solved or mitigated by making those healthcare services remote. However, now we have to deal with how to make rehabilitation remote, or we have to tackle new issues emerged by making rehabilitation remote, such as how to replicate physical interaction, how to assess the user's initial condition and make a rehab program, and how to evaluate the progress and efficacy of the rehabilitation program, and also how to grasp the daily physical and mental state should be dealt with. And also we have to think about the difficulty of switching heads in 1 to n remote interaction. And finally, there is a motivation issues such as I can't start or I can't continue. The approaches that we take is to develop an X-ray system to estimate mental and physical states through daily measurements by using always-on monitoring device in wristband form, and a system to support the creation and updating of care programs based on detailed assessment of physical functions using MR-Cube devices. MR-Cube stands for Multimodal Mixed Reality for Remote Rehab, such as MR-Cube Wear and MR-Cube Dummy. And we also develop an Excel system to appropriately convert and present the obtained states and care task execution status to remote parties and oneself in remote XR service encounter. And then in those environments, we apply several XR-driven techniques such as haptic retargeting and virtual co-embodiment. As for another kind of XR-driven techniques, we're going to develop mindset switch mechanism for 1 to n remote interaction. In this case, 1 means a small number of therapists or experts, and n means many users or patients. And as for 0 to n remote interaction, in this case, 0 means no therapist or expert. We're going to try to provide a reciprocal care platform in which each activity of each user in each community transformed appropriately through the XR environments. Then the final goal of this project is to build such a set of platform modules for telehealthcare services. That's all for today. Thank you for listening.